In the next step, I will walk you through drawing the base sketch for the rectangular boss. I will use these commands from the Sketcher workbench. So, in the CATIA window, let's insert a new geometrical set and name it rectangular boss. Next, I will copy the sketch from the circular boss and paste it under this geometrical sketch. I will use this sketch for reference and build on it. Let's hide the circular boss surface for better visibility. I will draw two centered rectangles and constrain them as shown. Next, I will draw two circles and constrain them. I will apply the corner command with radius 18 mm on all four corners of the outer rectangle. Next, I will add the circles here for the cutouts and holes on the outer frame. Moving on, I will use the quick trim command to remove unwanted edges. Next, I will apply the corner command between the circular and rectangular edges as shown. I might need to offset this curve at 0 mm to create a duplicate line and avoid errors. If you remember from our previous sessions, we created 3D profiles of sketches. These 3D profiles will be available independently in the graphics area. So, I will convert the outer frame profile, the rectangular boss and the bush circles into 3D profiles as shown. Notice all the 3D profiles listed under the Outputs branch of the Sketch 3. The sketch with all the required geometry is now complete. In the next step, we will create the surface for the rectangular boss and the base frame, using commands like extrude, trim and edge fillet on the surfaces. So, let's get into it. In order to extrude the rectangular profile, I will select the Extrude command from the Surfaces toolbar. Let's use the 3D profile of the rectangle that is visible on the graphics area. Note that I have updated the direction field to YZ plane. The height of the rectangular boss is 66 mm as seen in the drawing. I will extend this extrude to more than 66 mm. Next, I shall create a flat surface that intersects this rectangular surface. To do this, let's edit the sketch 2 and create another 3D profile. So, I will draw a horizontal line at a vertical distance of 66 mm. I will draw another horizontal line passing through the origin of base frame construction. I will convert these lines into 3D profiles so that I can use them for extrusion, even if this sketch is hidden. Let's extrude this line with mirrored extent checked and XY plane as the direction. Did you notice how all the sketches and surface features are being listed under the geometrical sets? CATIA considers surface features as geometrical elements. Only after thickness is added to these surfaces, the elements will start listing under the part body. This time, let's see how the trim operation works. I will select Trim from the Operations toolbar. I will select the rectangular and the flat surfaces as shown. Now, if I click on Extrude 3, I can switch between surfaces that need to be trimmed by clicking on the Other Side or Next Element button. Similarly, if I select Extrude 4, I will be able to switch the surfaces to be trimmed by clicking on the Other Side or Previous Element button. Once the correct parts of the surfaces are grayed out, I can click on OK to complete the trim command. We needn't join these surfaces as I used the trim command instead of split command. While we are here, let's apply edge fillets to the edges as shown. I will apply 9 mm fillet radius. I will also change the color of this rectangular boss from the Graphics Properties toolbar. Next, we shall create the surfaces required for constructing the base frame. I will hide the rectangular boss. I will insert a new geometrical set and name it Base. Let's use the 3D profile of the base frame to extrude in both directions normal to the YZ plane as shown. Now, I will also extrude the horizontal line in both directions normal to the XY plane as shown. We now have surfaces for the circular boss, rectangular boss and the base. Let's create solid bodies for these surfaces. In this step, we shall switch to Part Design workbench and use commands like Thick Surface and Split to create solid bodies of the surfaces. So, from the Start menu, I can click on Part Design to switch the workbench. I will right-click on the part body and then click on Define in Work Object. I will select the Thick Surface command from the Surface-Based Features toolbar as shown. Let's update the first offset value to 6 mm. I will select the flat surface here for the object to offset value. You can click on reverse direction if required and click on OK to complete this command. I will right-click on the thick surface, click on the thick surface object, and then click on Insert in a new body option. In order to differentiate the different bodies of the model, we can use these Boolean operations. I will now start a split command from the Surface-Based Features toolbar. If I select the extrude of the base frame profile, switch the splitting direction and click on the OK button, the split command is completed. Let's hide the surfaces to see how the split operation came out. I will now do another split operation. I will select the circular base, that is pink in color. Observe the split direction. Once I click on the OK button, we can see that the base is cut out with the profile of the circular boss. Let me repeat the same steps for the rectangular boss as well. I will start another split operation. I will select the rectangular boss surface that is orange in color in the graphics area and click on OK. The split command is now complete. The base is now cut out with the profile of the rectangular boss. Moving on, let's apply Thick Surface command to the bosses. First, I will insert a new body. Now let's start the Thick Surface command from the Surface-Based Features toolbar. I will update the first offset value to 6 mm. Select the circular boss for the object to offset field. After making sure the offset direction is correct, I will click on OK to complete this command. I will now repeat the thick surface feature on the rectangular boss as well. Let us next rename the solid bodies as shown. If I hide the pink and orange surfaces along with the 3D profiles, the entire solid body is clearly visible. Observe how the bosses are hollow from inside. Now let's go through the next steps. In this step, I will walk you through creating the bushes on top of the bosses as seen in the picture. I will create and use the same surface to cut through the bosses to make the holes for the bushes. First, I will insert a new geometrical set and name it bushes. We need to switch to Generative Shape Design workbench to create surfaces. I will now select the Extrude command from the Surfaces toolbar. I will select the 3D circular profile inside the circular boss. I will update the first limit dimension to 60 mm and the second limit dimension to -36 mm. If this error message pops up, it means that CATIA assumed the default plane on which it created the extrude. I will edit this extrude and update the direction field to YZ plane. Let's extrude the next 3D circular profile with the first limit as 90 mm in the upward direction and second limit as -51 mm in the other direction. Now I will repeat the extrude command on this third circular profile with the first limit as 78 mm and second limit as -9 mm in the other direction. I will change the color of these surfaces from the Graphics Properties toolbar. Let's apply split operations to create holes associated with these bushes. This operation is on the solid body, so we need to switch to Part Design workbench. I will right-click on the circular boss part body and then select the Define in Work Object option. Now I will start the split command from the Surface-based Features toolbar. I will click on the circular surface and update the direction to point outwards. Once I click on OK, the hole is formed. Let's repeat the same process for the other two bushes as well. Now, let's add thickness to these bush surfaces. Now, if I select the circular surface, then click on Thick Surface command from the Surface-based Features toolbar, update the first offset value to 6 mm, a thickened surface is formed. Let me repeat the same process for the other two surfaces of the bushes as well. I will define the rectangular boss as the work object to place the next feature under this part body. For this next bush, the thickness is 4.5 mm as calculated from the drawing. The thickness for the third bush is again 6 mm towards the inside of the surface. As you can see, all the surfaces of the bushes are now built into part bodies.